Okay, question number 4. A point P is moving along the curve with equation y equals to ax to the power 3 over 2 minus 12x in such a way that the x coordinate of P is increasing at a constant rate of 5 units per second. Okay, and find the rate of at which y coordinate is changing when x equals to 9. So what are we supposed to do? What is given to us is dx over dt. X coordinate of point P is changing at a rate of 5 units per second. So 5, what do we need to find? Dy over dt. Yeah, dy over dt we need to find when x equals to 9. And thirdly, a connecting equation is given to us. Y is equals to ax to the power 3 over 2 minus 12x. Okay, this is your equation. This is the rate of x, and this is your value of x at which y is changing at the rate. Okay, so this is the whole information that is given to us. So we will be solving this by chain rule. We know dy over dt is equals to dy over dx times dx over dt. Okay, so we know dx over dt, dy dt we need to find, and this is what we need to first finding out by using this equation by differentiating it. Okay, so let's do that. Differentiating that, dy by dx would be a little rearrangement is needed. So dy over dt would be a 3 over 2x 3 over 2 minus 1 minus 12. So what is 3 over 2 minus 1? It's 3 over 2 minus 2. So it will be 1 over 2. So let's substitute this in your required chain rule. And now it will give you dy over dt equals, write it like 3 over 2 ax to the power half minus 12 times dx over dt, and that is 5. And at what value we need dy over dt? At x equals to 9. So we need this to be at x equals to 9. So let's substitute x equals to 9. 3 over 2 a 9 to the power half minus 12 and whole multiplied by 5. So we will be getting 3 over 2 a times 3 minus 12 whole multiplied by 5. So 9 over 2a minus 12, and this will give you 45 over 2a minus 60. So they have also told us in the start to give the answer in terms of a. So yeah, give your answer in terms of a. So this is your final answer for part A of question number 4. Now let's see what is part B. Part B says, given that the curve has a minimum point at x equals to 1 over 4, find the value of a. So whenever we have a minimum point, that means we have a stationary point. At that point, dy by dx equals 0. And also they have given us the value of x at which dy by dx equals to 0. We need to put so that we can find the value of a. So first get back and see what was the dy by dx. So dy by curve has a minimum. So where we have differentiated it, I think so I have done dy by dx, but I wrote it here dy by dt. So this is your dy by dx. So yeah, take this. We have to put this equals to 0 to get the value of a. So dy by dx equals this at minimum. Yeah, we know that. At minimum, dy by dx equals to 0. So let's put this equals to 0, a times 3 over 2. And at what point do we have minimum? 1 over 4. So yeah, 1 over 4 to the power 1 over 2 minus 12. So you'll be having 3 over 2a. 1 over 4 under the root will give you 1 over 2 minus 12 equals 0. So this will give you 3a over 4 minus 12 equals 0. 3a over 4 equals 12, and 12 times 4 equals 3a, and a equals 48 over 3. That will give you 16. So from this working we get the value of a to be a equals to 16. So yeah, that's the whole working for question number 4. I hope you get it. If you have any problems or you think there is any error in this, you can comment us in the comment box. Thank you.